All right, so this is 3.1, determining functions and relations. The next section involves these terms and concepts about continuity. So if something's continuous, it's smooth. It's like a straight line. It's not disjunct or like kind of like hit or miss or blotchy. So when we're talking about something being discrete, if we look at this example here on the left, notice we have all of these dots, okay? These dots are going to make this one discrete because it's disjunct, all right? And the domain here, if we just look at our x values, so what do I mean by that? So if we look at this and we just drop out down that red dot, that would be -7. We go over here, that's 1. Then we go over here to this one and we trace it up, that's 5. This one we would drop down, 7, 8, and 10. So my domain would be -7, 1, 5, 7, 8, and 10. And then my range, I would do the same thing, but instead of tracing it to the x-axis, I would trace it to the y. So it would be -7, 0, 1, 2, 5, and 8. So one more time, it would be -7, 0, 1, 2, 5, and 8. Okay? And the order doesn't really matter here. Now, when we look at this one's continuous. Why? Because notice it's smooth. It's not broken up. Okay, I know it's kind of like bent, but it goes on all through those numbers. So it's going to be continuous. And my domain, this is kind of funky. Okay, this is where that inequality stuff comes from. All right, so what are my x values? Well, my smallest x value is right here, and my largest one would be like right here. So let's trace that up and trace that one down. So my x values would be in between these two numbers, which would be 8 and 8. So it'd be between -8 and 8. Now my range, right? This is my smallest range. Let's trace that over. My largest range is right here. So let's trace that over. So my y values are in between. We look at that, that's going to be -6 and 6. So it's a little bit about discrete and continuous. So let's continue on. So already I'm looking at this one on the left, and I can tell that this is going to be continuous. And since it is, all right, I'm going to have that x value that's going to be between two numbers. So let's look at this. Let's look at my smallest x value. That's right there. Let's trace that down. And right there, let's trace that down. So that's going to be between 0 and, what are we counting by? 5, so 45. And then for y, we're going to trace over the smallest and largest points. So this is my smallest y gets. So that's at what, 10? So we're going to have 10 is less than or equal to y, which is less than or equal to. Let's trace that over. And that looks like it's 70. Now over here on the right, this is discrete because it's all broken up. It's in pieces. Okay, notice all the little pieces here. My domain, well, these are going to be the numbers. So we're going to trace each of these points over. Okay, so that would be for the range. For the domain, we would trace them down. So if we trace it down, my domain is -7, -5, -3, -1, 1, 3, 5, and 7. Now for my range, I'm going to trace them over here to my y-axis. Okay, so that's all I'm doing. Now it's a little clustered, so I'm just going to erase that. So my y's go, let's see, 5, 4, 3, 2. Okay, so I'm right here. Now I'm starting to go back up. So 3, 4, 5, and 7. Now I don't technically need to put the 2 3s, the 2 4s, or 2 5s, but I wanted to make sure you guys saw that they're the same number of points there. All right, so let's look at this. It says domain and range in real life. The number of shoes, X, pairs of shoes can be expressed in the quantity Y equals 2X. All right, so we're just going to skip through this stuff right here because these are just more real life examples. All right, and I want to talk about, let's look at this. Identifying domain and range and your independent and dependent variables. So we're going to start here with Mr. Landry is driving to his hometown. It takes 4 hours to get there. The distance he travels at any time t is represented by the function d equals 55t, right, in inequality. So we have here, all right, we're going to have, let's see, we're going to have our distance needs to be less than or equal to 55t. Now, why? Because we're not always going to drive at 55 miles per hour. So write an inequality that represents the range. So this was the domain. So let me take this, my range function. Well, that's right there. In my domain, well, this is going to be t. So I can either drive for 0 minutes or I can drive for greater than 0 minutes. So there we have it. Now it says Mr. Landry is driving to his hometown. And it wants me to identify the independent variable. So that independent variable is time, and it's typically going to be time. And dependent is going to be distance. So let's talk about Johnny now. Johnny bought at most 10 tickets to a concert for him and his friends. The cost of each ticket was $12.50. Complete the table below. Is it possible to have the domain and range? So if we look at the table, it says 1 and $12.50, 2 and $25, 3 and $37, 4 and $50, 5, $62.50, 6, $75, 7 and $87.50, 8 and $100, 9, $112.50, and 10, $125. So in this case, I think it is possible to have these domains and ranges because notice my domain is 1, 2, 3. It's discrete. I can't buy like half a ticket. And then my range is $12.50, 25, which is 2 times $12.50, $37.50, which is 3 times that. So my independent variable is going to be number of tickets. And what is the dependent variable? Okay, this is going to be cost or price. So Pete's Pizza Parlor charges $5 for a large pizza with no toppings. They charge an additional $1.50 for each of their 5 specialty toppings, and taxes included. So Jorge went to pick up his order. They said the total bill was $9.50. Could this be correct? Well, what we gotta figure out is, well, does it make sense? So what we're gonna do is we're gonna say your total bill was $9.50, and we're gonna take off the price of the pizza, which is $5. And that's gonna leave me with $4.50 worth of toppings, okay? And then to figure it out, if I can get a whole number of toppings, we're simply just gonna do 450 divided by 150. If we get a whole number, we know this is possible, and we do. It's 3. So it is possible, so we're gonna write yes. Now, Susan went to pick up her order, and they said she owed $10.25. Could this be correct? Now I'm going to go with no right off the bat because I really don't think we can end in 25 cents here. I think it would have to be either 50 or like a full dollar. So we're going to do the same thing. We're going to do 10.25 minus $5. We're going to get 5.25. Then we're going to do 5.25 and we're going to divide it by 150. And notice we're going to get 3.5. And you can't get half a topping. It's either there or it's not. So no, this is not possible. All right, so these just ask you to determine whether the relation is a function or not. So what I'm going to have you guys do is I'm going to stop this and I'm going to have you guys work on these on your own.